This is pre-AP pre-calculus, notes 5.4, connecting the equation of a rational function to its graph. Focus on asymptotic behavior. Quick review. How do you find vertical asymptotes? Excuse me. Vertical asymptote is the non-canceling factor in the denominator. Set that equal to 0 and solve it. And that's the location of your vertical asymptote. How do you find zeros of the function? Zeros come from non-canceling factors in the numerator. So I'd set negative 2x plus 3 equal to 0, and we'd solve it. How do we find holes? Well, holes come from canceling factors from the numerator and denominator. We'd set x plus 1 equal to 0, and we would solve it. How do you find the y-intercept? Well, you look at the standard form of the rational function, which means it's all multiplied out, and you divide the constants. That would give you the y-intercept. So enough of the review. Let's go with some new stuff. Please note, your notes may have this symbol incorrect. I have corrected it. I had the wrong symbol there. So if yours says something other than greater than, change it. Existence of horizontal asymptotes. There are 3 rules that we're going to use to determine if a horizontal asymptote exists and what it is. We're assuming in each of these cases that n is the degree of the numerator and d is the degree of the denominator. If n's less than d, then there's going to be a horizontal asymptote at y equals 0. It means that the top degree is less than the bottom degree. If the degrees are equal of the numerator and denominator, then there's going to be a horizontal asymptote at the lead coefficient of the numerator divided by the lead coefficient of the denominator. If n is bigger than d, if the top is growing faster than the bottom, if the degree is bigger, then there is no horizontal asymptote. Before we get all the way into the horizontal asymptotes, let's discuss its cousin, the slant asymptote. A slant asymptote can exist if there's no horizontal asymptote. And there's no horizontal asymptote if the degree of the numerator is bigger than the bottom. So more specifically, there is a slant asymptote if the degree of the numerator is exactly 1 more than the degree of the denominator. And when that happens, if you want to find the location of the slant asymptote, we're simply going to divide the numerator, the top, by the denominator, the bottom, using a long division. We are looking for a linear equation, which means that we are going to ignore the remainder. Straight up, ignore it. Let's look at some examples and see if we can figure how this stuff works. Number 1, determine if each equation has a horizontal or slant asymptote and give a reason. Then find the horizontal or slant asymptote. So to determine if it has a horizontal asymptote, we simply look at the leading terms. Which exponent's bigger, the 1 or the 2? So the 1, which is on top, is smaller than the bottom. So this tells us that we have a horizontal asymptote at y equals 0. If n is less than d, which is the case, there's a horizontal asymptote at y equals 0. So we're going to write this down. F of x has a horizontal asymptote. At y equals 0. Because the degree of the numerator is less than the degree of the denominator. It is a mouthful. You could also change the order of how you write this answer and say f of x degree in the numerator is less than the degree of the denominator. Therefore, f of x has a horizontal asymptote at y equals 0. Looking at the next one, same thing. Look at the leading terms. This is going to have a horizontal asymptote at y equals 0. I am writing the identical answer. Let's look at number 3. Pardon my cough here. These have the same degree. When it has the same degree, there's a horizontal asymptote at y equals, you just divide the lead coefficients. So it's at -1, y equals -1. It's that simple. So I'm going to write this answer in the opposite order that I wrote the first two. Oh, and this last one, yeah, it was f. H of x has the same degree in the numerator and denominator. I'm giving the reason first. Therefore, h of x has a horizontal asymptote at y equals -2/2, which is -1. Number 4, well, this is the same type of problem as the last one. The degree of the numerator and denominator is the same. I'm just going to copy most of this answer down here, not all of it. The degree is the same, so we have a horizontal asymptote at y equals 2/1, which is 2. So h of x has the same degree in the numerator as the denominator. Therefore, h of x has a horizontal asymptote at y equals 2/1, which is 2. Number 5. If you compare these, the top's growing faster than the bottom. The degree of the numerator is bigger than the degree of the denominator. When this happens, there is no horizontal asymptote. There is a slant if the degree of the top is exactly 1 more than the degree of the bottom. So g of x has a slant asymptote because the degree of the numerator is 1 more than the degree of the denominator. How do we find it? We take the numerator and we divide it using long division by the denominator. Keep in mind the denominator is x minus 1, so what would make that equal to 0? We'll be putting a 1 into that, so we're dividing it by 1. So we do long division. We get a remainder of 6, which we ignore. The slant, let me do better than that. G of x has a slant asymptote at y equals 1x plus 4. This will always be a linear equation. Number 6, compare the degree of the numerator and denominator. If we compare that degree, we'll see the top is exactly 1 more than the bottom. So I'm going to save myself a little bit of time here in this video. And I'm just going to write the same thing here by copying and pasting it. I know, you can't do it. Poor you. All right. Now, We got to be super careful here. The denominator is simply not x minus a number or x plus a number. The denominator is 2 times x plus 2. If we were to factor the numerator to see if things would cancel, nothing does. So I am urging some extreme caution here. Caution comes from this 2. So watch what happens with this 2, because we cannot ignore it. Cannot ignore it. So let me write down what the caution is going to mean. We must divide x squared plus 5x minus 6 by 2 and by x plus 2. We have to do them both. In the order in which you do them doesn't matter. I'm going to do the x plus 2 first. So I'm going to do synthetic division. I got my coefficients of the numerator, and I'm dividing it by -2 because that's what's going to make the bottom a 0. And I do it like I normally do it, but I don't want to forget about this caution that I have here, this 2. Now I've just divided that by x plus 2. Now I'm going to divide that by this 2 that I'm super worried that you're going to forget about. So then I divide each of these by 2. That's coming from right here. Therefore, g of x has a slant asymptote at y equals 1/2 x minus 7/2. Super worried that you're going to forget about the fact that you have to divide by this 2 here. So make a note in your notes that I'm super worried about it. The graph of this function is pictured. Find the equation of the asymptote of the graph, and then draw it. Well, this is a cautionary tale again. First of all, we know there's a slant because the directions tell us, but the numerator is growing exactly, or his degree is 1 more than the denominator. I'm going to rewrite this a little bit here, that g of x, this denominator, is 3 times the sum of x and 2. The numerator, I could factor out a -2. The rest of it doesn't factor. There's really no point in doing it, so I'm just going to leave this how it was. This is a cautionary tale again. We have to divide by 3 when we're done. So I take the lead coefficient, and I take the coefficients of the numerator, not just the lead, all of them, and I'm going to divide that by -2 because that would make the denominator a 0. Excuse me. I had a frog in my throat all morning. I had went to a restaurant last night and ate frog legs. Apparently one of the frogs had the rest of the body attached to it, and it's been in my throat forever. Hope I don't die from it. It is frustrating. Now, caution once again. We have to divide each of these by 3 because we've already divided by the x plus 2, but we haven't divided by the 3. So function g of x has a slant asymptote at y equals -2/3 plus 2/3. We're supposed to graph that. Let me read the directions again. Find the equations of the asymptotes. We didn't do the vertical one. So this is going to have a vertical asymptote at x equals -2, because that's a non-canceling factor in the denominator. Put that bad boy right here. Let me put this in red so we can see it better. And then we have found the slant asymptote, which had a y-intercept of 2/3. It's about here. And it had a slope of -2/3. So I'm just going to try to get this scaled a little bit. Don't do what I'm doing. If I put this here and I go down 2 and to the right 3, I'm going to get my scale better. Once again, you don't have this luxury because you don't have a magical iPad. But if I then take these points that I just did and I move them down so the y-intercept's about 2/3, it's going to give me this. Connect it with a line-ish. This is a slant asymptote. Any asymptote should be dashed. I think we've answered the question now. Let's just make sure. Find the equation of the asymptotes. So I should probably write down g of x has a vertical asymptote at x equals -2. So I did that, and then graph them. Did that as well. So, all right, we're finished. Your homework would be obviously section 5.4. There's also a free response question that goes with it. Thank you very much.